We are about to start this, we will be starting this webinar in just a couple of minutes, just waiting for people to log in. Hey, people, I think it's moving quite quickly. So what I propose that we do is, in the meantime, as people are logging in, so this webinar is this panel discussion we're very excited about is digitalization and AI. We are going to be focusing on transforming solar project execution and asset management. And this webinar is organized by the Middle East Solar Industry Association. So I will take advantage of this opportunity to tell you just quickly who we are. We are the oldest and probably one of the most well-known non-for-profit association focused on the solar industry, bringing together the Middle East and North Africa. We have over 80 company members, some of which are on this panel today, such as Huawei and Aqua. And we are really happy to be hosting these webinars. You can find this webinar and other on our YouTube channel. Link here. No, this is not really a thing. There will be no link, but we will be sharing with all of you any way you can connect with us. So today on this webinar, and I will start with our dear Hiba Derneika, who's the Director and Head of Digital Software Factory for Portfolio Management at Aqua Power. She is here today along with Giuseppe Ferraro, who's the Director of Digitalization, Renewables Optimization Team at Green Power Monitor. Mr. Mohamed El Khatib, who's the Regional Manager, MEA at Above Surveying. Correct me if above surveying or just above? Above?
It's the same. It's
okay,
above.
great.
We are trying to go more above-ish now.
You like to go above. Okay, that works. And then finally, actually not finally, but last but not least, Mr. Scott Nichols, Regional Sales Manager at 3E. And finally, our wonderful moderator today is going to be Mr. Rizwan Razak, Chief Technology Officer at Huawei, that I will hand the baton to for today.
Great, thank you, Hind, and I hope everybody is doing well this morning or this afternoon, depending on whereabouts you are in the world. And if you are listening back to the webinar, welcome. So my name is Rizwan. I'm the CTO for the Middle East and Africa region. And as described, we'll be talking about digitalization and AI. So let's go into the first specific topic, why digitalization and AI matter in solar assets themselves. So in that regards, I think the first would be Hiba, if that is possible for you to just answer that. Why digitalization and AI matter in the solar assets themselves?
Assalamu alaikum, good morning. Thank you for this opportunity to discuss along with my colleagues on digitalization for the solar industry. So let's start with digitalization is across all technologies and all our life, day-to-day life. And in focus for the solar industry, the digitalization has will boost the efficiency and the maintenance and the productivity of the solar plant. The digitalization will start right from during the construction and will continue to the operations. So it will help to have full chain of improvement throughout the right from the like bid award or like development of the like theoretical development of the energy the plant up to during the life cycle of the operation maintenance. So it covers everything from like we will discuss later on about like BIM, we'll discuss about like predictive maintenance, performance, and so on. So digitalization is the key moving forward to monitor and get benefit of the a low cost, we call it low cost plant energy production across the life cycle of the power generation of the plant.
Great, thank you, Hiba, for that. So we'll head over to Mohammed now from above, and your point of view on this particular topic of how AI and digitalization matter in the solar.
Okay, thank you very much for the invitation. Thanks for Rizwan for the question. Let me first start maybe talking about digitalization in general. What is digitalization? Because we hear it a lot. We don't really know sometimes when to use it. Digitalization in our business is to convert some work, manual work or physical presence on site into a virtual model where we can manage it remotely and benefit from this data for anything like in the maintenance or in the construction. But most important is to know what to digitalize. We always talk about digitalization, but we need to know what to digitalize in our business. So even before construction, adding to Hiba, we can start digitalization. And if you start in the development, we can even digitalize. If you do the topography with a drone, for example, on a geospatial map, you can digitalize the tree or any hills for an accurate shading analysis. So we need to know the object, the parameter that we need to digitalize. How to fill it in with data is very important, and then use AI at the end for the data analysis. Take this webinar today as an example. It's a seminar digitalized. The object are the location, us, our voices, and the AI is when someone is speaking, you have a highlight on his square. Back to solar, why digitalization is needed, I can tell you the whys. First of all, we are seeing lately a big growth in the solar industry. Assets are moving from 25 years to 40 years. And those projects are divided in multiple geographies all over the world. We have also a shortage of labor. So to manage all this big asset around the world, you need more people. So to manage it in an easy way, you need to have a digital tool. Of course, I insist here to have a user-friendly digital tool because not all labels are having the same up-to-date experience. You need also to have transparency between all the stakeholders and all parties related to the project. There, the digitalization will play a big role because it's very reliable. And yeah, and the cost, for sure, the cost is very needed. And also the old school deliverable are not, should be up to date, should match with the new PV modeling softwares and digital twins. That's why digitalization can manage and have a good quality assurance.
Great, thank you, Mohammed, for that. So just to kind of interrupt between the speakers here now, from Huawei, we're providing with over 8 years in Huawei. Myself, we've seen a lot of development in the inverter market. And within that, we've brought out digitalized tools such as the IV curve diagnostics. So this is already becoming incorporated in the component selection in the solar projects themselves. Now I'll hand it over to GPM, Green Power Monitoring, to give their insight in the topic of digitalization and how AI takes in the solar assets.
Yeah, thanks for that, and thanks to everyone for joining today and spending some time with us. In terms of optimization, yeah, we've been doing many things in looking at how AI can optimize solar energy generation. One of our main focuses is on losses identification, but we've also been spending a lot of time on data classification and standardization, and I will be discussing that later on. Most of the times we take data for granted, but in reality, that's not always the case. Other things that we feel are very important in the area of AI and digitalization is performance benchmarking. So looking at how assets are performing against each other and give indications on whether there are any issues based on that. Other things that probably we take for granted, but resource data cleaning, so offering a clean source of reference data for performance assessment is something that most of the people take for granted, but it's not as trivial as it might sound. Resource forecasting and weather forecasting is another one where AI, machine learning play a very, very important role. Last but not least, what I want to add is that we think about renewables as digitalized industries. I would argue that they are digitized, but not very well digitalized. And the difference is that we use the digital means, but most of the times, not all the stakeholders in the value chain are connected. And digitalization comes when all the stakeholders offering different added values to the industry come together to digitalize the whole of the industry. And that's something that is a work in progress for the whole industry.
Great, thank you for that. So we'll see what we have from Scott now, from your point of view on the topic of how the digitization and AI matter in solar.
Good morning or good afternoon to some people. Depends on where you are. So thank you for the invitation on behalf of 3E. So from a digitization point of view, 3E are very much front and center. So for nearly 25 years in the renewable industry, expert services and digitization is what we do every day. So anything from an idea, even before a project development or a bankability study, yield assessment, etc., all the way through to digitization of asset ownership, asset management, and analyzing data. It's really about removing that manual process every day in everybody's lives. We do it every day, sometimes by default without realizing we still do that. But it's really about removing those inefficiencies, removing the cost or the cost associated with manual processes, and really using data. So we all use data every day in the solar industry world, sometimes efficiently, sometimes inefficiently, but it's really about that granular data in terms of the yield performance, the expectation life of the assets over time. The longevity of behavior of assets is the important part of life. So when we all fixate on certain parts of our industry, whether you're construction, whether you're implementation, whether you're managing or maintaining assets, every single part of that journey is some form of digitization. And that's really what it's about. And I'm happy to be here on that call.
Great. Thank you, Scott, for that. So let's dive into a bit more detail of this particular topic and look at what kind of data do we actually need in order to make the assets more digitalized, and what kind of granularity of data we require, whether it is at a inception stage of the project or whether it is once it's commissioned and handed over. So first of all, I'll hand it over to GPM on their point of view on the question of what kind of plant data would be required from the projects themselves.
Yeah, I'll probably point out that data is the key, is the fuel of digitalization or digitization, how we want to call it. And from our point of view, monitoring and predictive analytics is there is a variety of data. But what I would like to point out is, in terms of the data that are supplied from the assets nowadays, there is no doubt that there is most of the data that are needed to ensure that we can predict life, we can optimize, and we can do a good job at using digitalization to our advantage. What we'll probably argue is that the categorization of data, so knowing what data is referring to, is quite a challenge. If you just consider the variety of the size and the variety of the devices that are deployed, especially in the MENA region, where plants are becoming gigantic, and if you don't really know what each data is for and where it's coming from, you might struggle along the multiple steps that are needed to deploy the assets. So from building to maintenance and to optimize. Just imagine that you think that some data is coming from a specific device, then you send out operation and maintenance fleets, and they realize that they got completely wrong data, and that the panels or the devices they were trying to replace are completely wrong, and then they have to start wandering around and trying to identify what it is. If you consider that all of this is usually happening in very extreme conditions, then you can imagine what kind of challenge we've got up there.
Definitely. So thank you very much for that. So let's go over to Mohammed on the pre-construction stage, on the kind of surveying data that you would be requiring, and what you feel from your perspective is the important data required in order to make the assets more digitalized.
Thank you. Okay, maybe let's go back a little bit 20 years back, okay, and talk about the tools that we had that time. It was, if you want to do any site survey, you need to go on site. You had a mobile. It was not a smartphone yet. You had maybe the A4 layout and a camera, if the mobile camera was not good. So the site survey is to find any deviation at the beginning or any problem or anything. This was the data that is needed. You don't have any energy during the installation, during the construction. You have still the construction to be done. So this was the tool before 20 years. Maybe after 10 years, we had, I don't want to say the name of the application, but we had the chatting application where you can just share picture, but there was a limitation in the data and also disconnection of all these tools. Nowadays, I can just give a direct example, so it will be more clear, a direct application. If you are on site, having a digital tool, which is in this case, the smartphone application and the portal, both applications are having the project as orthomosaic, geolocated, overlaid with the CAD drawing, geolocated, digitalization each object. Again, not each object, each relevant object, like the panel, the inverter, and everything you need to digitalize, transformer, all geolocated. So if you are on site, you just can do the survey, find anything, take a picture. In this case, the data is the picture. This is the information that we need to deliver to, I don't know, to your boss or to the EPC or to the developer, because they are all on the same platform, related to the same platform. You can create a task, assign it to someone. This someone can be anyone, okay, that has to have access to this platform, okay, and the problem will be solved remotely, faster, and you will save a lot of time. So here you can engage with the information that you have on site easily, connected with other parties, and of course have more efficient time than before. So yeah, the data during construction is this. I mean, I'm not coming from a PC background, but I think this is what needs to be done.
Definitely, yeah. So I can definitely agree with you on that. The technology has already adopted over the years, where tools such as Google Earth, for example, how we are able to just
exactly
drill down into project locations and really assess what we'll be really reviewing on site. So again, anything physical required on site can be reduced, obviously from a safety aspect, etc.
I want to add something here. Exactly, and you just gave me an idea. Another source of data during the construction is like using other technologies like drone. So if you have a drone over this this plant, it will collect data of the construction. So again, the first layer will be the orthomosaic geolocated, and the last layer will be the CAD drawing. In between, you will have every time what's happening on site, maybe before each milestone. So this is another source of data where you can really track what's happening on site remotely. Imagine you are here in Dubai, you have a project in Africa. So you need someone to deliver this data for you in a reliable way. So
Definitely.
Yeah, this is another source of data.
Thank you, Mohammed, for that. So I'll look at it from a different perspective now. So from Aqua Power and from Hiba, what was your take on this particular topic?
Okay, so let me tell you our point of view, because we are like as a developer, at the same time we have NOMAG as the operation maintenance. And luckily I was the head of a monitoring and prediction center for NOMAG, and now I moved to Aqua to digitalize the construction phase. So I have the two pictures to be seen. And to second Muhammad on the part of construction, the digitalization will work on several aspects. As you mentioned, you will have a platform, and all the stakeholders, especially EPC, owner engineers, everyone will have access to that platform and follow the workflows in the same platform, and all the communication will be there, and we'll have the real progress. And as you mentioned, whether satellite images or drones will assure or confirm the real progress when it comes to the updates or reporting on where do we stand in terms of like construction, and we know exactly at the early stage whether we are on the right track toward commissioning dates or we have delays. Now the technology is much more in advance. We work on capabilities to even through drones do the quality inspection. instead of asking people to go and do the roam around, especially for solar. It's a vast area. So imagine the amount, the effort of, and the time the people will go to check all the vertical post installation, the torque modules, and all these aspects. With digitalization, with the artificial intelligence on top of it, scan the area, detect what has to be installed per tasks, because it will be like defined by the project schedule, and see how it's like installed. Is the installation is correct or not? Because, for example, in the solar, if our vertical post is not installed correctly, everything will be delayed. So these aspects of really critical milestones when it comes to quality, which plays a big role on the impact on the project, as well as the life cycle when it comes to operations. This aspect we are now working toward, like POC, proof of concepts, to cover all these aspects. Now, at the end of the project construction, when we hand over to the operation and maintenance, with the digitalization, we are changing the approach during the construction from project wise to asset wise. So at the end, when you reach to the commissioning, you have an asset and you have all the data related to that particular asset: supplier, documents, power curves, quality inspection, all the history in one platform. And then from there, so you have one digital twin during construction, then you convert this digital twin into operations. And in operations here, you will go through the performance monitoring, predictive monitorings, again, another AI tools where to monitor the neighboring of the panels to see the performance, compare the area, compare based on the like expected performance with the ambient conditions, DNIs on all these aspects, and the focus angle, etc. So with this chain, we will have the full capability to really see and anticipate, and you don't need to have people on site. The idea is you might have a couple of plants, you have one centralized maintenance room to get the data, hourly basis, daily basis, depending on the needs. And then from that, you can directly plan the maintenance to replace a panel and so on, with the data being stored and received on a daily basis. And again, drones here plays another role during the operations to detect the heat. From there, you can even detect whether if solar a panel is defectuous, yes or no, and you have the heat map of your entire area to decide to make the decision. So it will not, as we discussed, it will not replace the team. It's more about having the right tool to help you to make the decision and prioritize the work, the maintenance work activities, because you cannot work across the entire area. You will have to prioritize, and with this all AI and digitalization, we'll be able to prioritize and do the job accordingly.
Definitely. Thank you very much for that. So from Scott, what's your take on this particular topic now?
I think the core part of the discussion is really about understanding the data. That's a fundamental number one. Within 3E, within the Synaptic Digital Twin platform, which is what I do every day, it's really about inciting operational people, department level. Everybody has a different need. When we turn and log on our computers every day, it's a different requirement in different parts of a business. So whether that's financial, whether it's performance improvement, whether it's yield improvement, whether it's actually improving the amount of efficiencies back to stabilizing grids, etc. That's really the key to understanding data. And it's about cleaning the data. There's good data, there's bad data. So that's the fundamental number one. The second side of that is about inciting from a dashboard point of view, but also what do you do with that data? We look at data from a granularity level down to 5-minute data within certain platforms, digital twins, but it's also about the fundamentals of things like physics-based algorithms. I'm a commercial guy. I'm not a super scientist, but behind all this, there are key fundamentals of life behind all these engines. But it's really about what you get out of it. Remove that heavy lifting. Improving efficiencies in our manual processes, and really work on the exceptions-based rules rather than going to work and doing the same thing every day. So from 3E's point of view, it's really about being more efficient, being scalable. Working remotely is what we all do every day. So yeah, that's really what 3E is about.
Great,
yeah.
Thank you for that. So I think one of the topics which would kind of go into hand in hand here is, as we are becoming more digitalized, and we've already seen an evolution of the solar assets within the last 10 years. And as clearly mentioned, we are looking at very large utility scale plants within the region of gigawatt scale. Now, obviously, security is an aspect of key concerns now. So I would like to understand from Hiba now your take on the aspect of the security of the data as we go into a more digital era now.
I fully agree, and this is especially for like energy sector. We consider the data as a classified data, especially in our region. So we need to protect the data. And now with the like Aqua approach is to create their own data lake, private cloud in every country to meet the country regulation, whether UAE, Saudi, etc. So once we own our cloud, private cloud, let's say, in the country, we are able to develop and then have the data stream to our servers, or like Azure or any a cloud supplier, but the servers are in the region. And this is like, to be honest, any tool in the market, if they use classified data, they have to go toward this approach. Believe me, when I was doing some digital assessment in the last couple of months, I had to automatically block or reject very important tools. They are capable to cover all our business needs. However, the critical aspect, which data hosting and the capability to host their tool in KSA or in UAE, was not available. So we had to block them, because at the end we are part of the environment here, and we are the ecosystem. And if you want to meet and then have the ability to follow the NCA regulations or UAE regulations, we have to meet that. So this is a critical point. We have a couple of let's say cybersecurity approach. Whether firewalls, data diodes, especially when we want to remote monitor solar plants. This is the vision of operating and monitoring solar plant would be remote monitoring. And for that, and sometimes you need to control, and you need to have a full pledge of security, secured platform and communication. And this is what Aqua Power is doing. And security is not only about data, security is about accessing the plants. And with that, again, drones would be there, CCTV cameras. We are working as well with a couple of suppliers to implement detectors for like people where they enter in restricted areas. This is another way of security. You have the data security and you have the physical security. And as well in the market now, you see so many technology. I don't need to mention the names, but we are working closely with a couple of proof of concepts to cover all aspects of security.
Thank you very much, Hiba, on that. So from GPM's perspective, what's your take, and what are you seeing being adapted within the market in terms of the data security from your organization?
Yeah, what we're seeing is a continuous increase in needs to ensure that the data is stored in a safe way, and we are continuously challenged to improve and to raise the bar for ensuring that our customers keep the trust in our solutions. As I mentioned before, data again is king. Therefore, for us is quite important that we can essentially follow the data across the whole value chain. We are lucky enough that we can follow it from the SCADA installation up to the monitoring and revamping of assets. So I think that for us is quite a paramount requirement, and we are continuously focusing on that, adapting the solutions that we had in the past, because Green Power Monitor is a company that has been in the industry for quite a long time, to the new needs. So what we are doing at the moment is combining and getting out an hybrid approach. So we used to have on-site ways of storing data, and now we are combining those with the solutions that we have acquired in the cloud space. So we are trying to get out in the market with the best of the two worlds. We are there with the wind solutions in Horizon that got launched a few months ago, and in early 2024 we're going to be launching the solar solution, combining multi-technology across solar, wind, and storage.
Great, thank you. So, do you see any differences? As we said, we're looking within a region of a gigawatt scale plants here in the region. So, what's your take on in regards to other markets and specifically within the GCC region of the data security? Are we following a trend of other markets, or is it vice versa?
I think what we've seen is that we are influencing in a different way. The size matters, and we are pushing the boundaries in the MENA region of what's feasible, because when you have to connect so many devices into SCADA systems, I think that the MENA region is pushing the boundaries in that respect. So we are following, but we are at the same time leading. It's a continuously evolving industry, and therefore what we're seeing is that we are inheriting the developments that were made in other regions, but we are pushing thanks to the size. I mean, the blessing that we've got in the MENA region with high sources of irradiance is a blessing, but at the same time is a challenge, I would probably say. So we are pushing the boundaries even forward, and then what will be developed for the MENA region will then be deployed in other regions, because I'm sure that other regions will follow.
Thank you very much for that. So, if we look at the Middle East, the smart grid networks expected to grow from 2.5 billion to over 5 billion from 2020 to 2027. So these are already trends that we're seeing within the market itself, and specifically within the GCC itself. So, Scott, what's your perspective on this particular topic, on the aspect of how things are moving forward, and how you see it differ from the UK and within the region of the Middle East?
Yeah, I think we're in a position in the Middle East where it's very much an immature market. It's looking at what's available around the world is key. Understanding, from a technology point of view, acquiring the best, whether that's hardware or software is also key. There's other markets like the UK, which is very mature, very old, very much driven by policy, and that takes a lot of time to sort of change. 10 years plus to get any connection to the grid is a normal way of life in UK and mainly Europe as well. So with that in mind, I think everybody's looking at the MEA region and saying, okay, let's work on what we do well, but try and do it better for tomorrow's world. And I think the Middle East especially is taking ownership of that, understanding it, and doing things today and tomorrow for a more inclusive, more performance related, better world. And when you talk about gigawatts, UK generally, our biggest plant and solar is 373 megawatts. So that's just the scale of and that's online February next year. So scalability point of view, completely different scalability. But precisely, it's still about managing the assets. So whether you have one solar array or 1 million solar arrays anywhere in the world, it's still about the performance improvement, and that's really what it's about. And one key thing before I hand back over to you, Rizwan, it's really about the data. So today, we all talk about the cloud, we all talk about, all these cloud services and things like that, but within 3E, you can actually go to the endpoint in a data center and see your rack with all your data within it, because ultimately it's not 3E's data, it's our client's data. It's a data warehouse, as we all understand the terminology. So there is also an endpoint. So when you look at in country or in region, 3E facilitates that everywhere in the world to put a data center in respective of clients' needs anywhere. So yeah.
So I think that leads me on to kind of the next kind of point of view on how to clean that data and how to really action that data itself. So Scott, what's your view on that, on the data that is coming available within the kind of digital era? What's your point on that?
Yeah, so cleaning data is something which is automated within our world inside 3E. It's critical because we are very much hardware agnostic. You know, it doesn't matter whether it's a inverter portal, it doesn't matter whether it's a certain data locker or certain SCADA system. That's the key part of what we do, and because we're agnostic, that's also an important message to understand. It's really client's data. It's really cleaning the data automatically. Nobody knows, you know, ultimately within the timestamp what's gone wrong. But from a 3E, from a physics-based algorithms, we understand that, and that's really the machine learning tool and the engine behind what we do every day.
Definitely. So from Huawei side, we've already seen the data is key, obviously, to develop into the next features, etc. So algorithms from that data is the important aspect to kind of really gain to the next era of the new features such as IV curve, diagnostic down to module level data or even string level data. Now, obviously, in gigawatt scale plants, do we need that data? What's the importance of that? So from GPM, what's your take on cleaning that data and having what type of data available on the plants?
Yeah, I would probably say, repeat what I mentioned at the beginning. I said that data is the fuel of digitalization. I'll probably add that data is king, but not any data, because as we have heard, bad data could be even a liability because you have to store them, so pay for the storage space, ensure that no one breaks in, and therefore you might liable with your customers. So good data, when I say good data, I mean data is classified according to recognized taxonomy. So we have spent a lot of effort in adopting IC and the orange button taxonomy in a way that we know that data is always classifiable. It's always up to the standard and is usable straight away. And this is a fundamental requirement for the enablement of AI and machine learning. When we started deploying some of the many algorithms that we've got on the machine learning side, what we realized is that having the right data that could help us deploying the algorithms was the key paramount factor that we had to deal with. We went and developed algorithms that will enable us to automatically clean data. So using natural language processing, which is a useful branch of AI, to essentially assign and categorize data in an automatic way. And that was a breakthrough because using something that is automatic, you can use cosine similarity or word movers distance to vectorize the data and then assign some meaning to the data in a way that then things that were assigned the early days or that continuously are assigned by customers according to their needs in a very flexible way then get transformed into something that is taxonomically relevant. And that's not relevant just for us. Going back to the discussion we had about the difference between digitalization and digitization, we are opening up our gates to ensure that more and more customers can use the work that we have done. We've done that as DMV in the maritime industry, and we are doing that in the renewable energy industry. So ensuring that everyone talks the same language is one of our ambitions. So that data is portable, not if you are only working with GPM, but if you're going to be working with other partners around the world.
Great, thank you for that. So the kind of the next area is let's look at some example cases potentially of where we have come across this. So Mohammed, what's your take on cases where you've seen or witnessed the digital era and the AI take into effect within your organization?
Okay. Let's go back to the construction where you digitalize the object. Okay, you give it like a birth certificate, which is the geolocation. Okay, now if you come to the commissioning phase or to the handover phase, you need to give it an ID. And for example, I can give you, I'm giving you now an example, particular example into the 3 phases. During the commissioning, what you can do with the digital tool, for example, scan the serial number of the PV panel on site with the mobile app that's related to the same CAD geolocated in the portal. And also you can onboard all the other relevant testing, EL testing, flash testing, whatever you have, you can also onboard it on the same history of this object, which is, for example, the PV panel. So during the O&M, if you are having this digitalization, if you did it before, then you are prepared and having good foundation for a smart O&M. For example, you have scanned the serial numbers of the PV module, and then you did the thermographic inspection of the plant during the handover of the O&M, and you found out like a concentrated thermal defects in one zone. Okay, because we are not a real-time monitoring. You need to interact with the tool to have the data. So you did like a thermographic inspection of a plant that was digitalized before, where you have scanned the serial number without drone, where you did a lot of things manually on site, okay, at the beginning for one time to give it again a birth certificate and ID. Then when you see that all the panels are, the defects are focused in one area, in one zone, you are a little bit worried. Why are they there? So if you go on site, maybe take some visual inspection with the mobile app. Visual inspection is also like, it's a picture that you take geolocated to the object. Maybe you can find, I don't know, a backsheet problem or anything. So the concentration of the PV panels of the thermal defects in one area will give you the idea to go to digital twin and maybe filter all these panels based on the batch. Batch is a part of the serial number that you have scanned before. So I mean, using this old data in the smart O&M. Through the batch, you can know, like, I think all the attendees knows what the batch is. It's like the family of this PV panel that has been manufactured same time on the same pallet, etc. Through this process and digital twin, you might find that there is a backsheet problem related to this batch. It means a manufacturing problem, and you are prepared, having a good foundation for a warranty claim. A warranty claim can be for all the PV panels related to the same batch. And this you can also relate to other components on site. So this is like a particular example in how this can be used on site.
Great, thank you very much for that. So from a plant perspective and a developer, Hiba, what's your take on this?
Okay, so actually I second very well Muhammad and Gusebe, like all of the team spoke correctly. So to Muhammad's point, the batch is critical, and this actually, if we follow the same approach that we start from during construction to be digitalized, we know exactly that this will help us if we have multiple suppliers. Not even for the batch, if we have multiple suppliers, and then we can really do a revision of the vendor management qualification. So this to complete your chain, and then from there we don't need to go to the operation maintenance, because these exercises can be done in the commissioning. We list that, and then we know that moving forward with the new projects, we should avoid the supplier if we have this digitalized processes, because any new development of a new plant, we get the lesson learned from all the previous similar technologies, and then what was the challenges, either during the commissioning, during construction, commissioning, and operations. If, for example, we have a repetitive failure for a transformer, this means that we have an issue with this supplier we need to avoid, or even a switch, or even a small aspect that can break and how we call stop the production, energy production, and impact our commitment, or purchase agreement with the grid. So this is correct. And one point I want to discuss about, like when you talk about data, is a very valid point, especially during the monitoring. Garbage in, garbage out. It's clear, and for that, the core is really data cleansing, and this is where I see the biggest area of opportunity for data scientists to do these data analysis and data processing. And for that, like I'm not into deep technology in terms of like the algorithm that was mentioned by Giuseppe, but the approach is correct. And then the first thing when I was in leading the MPC, the first thing that we need to check if the sensor is correct or yes or not. You know, this is the critical aspect. And so many cases where it's just about a sensor issue, not a real case. And this where the algorithm that will be put, whether comparing the neighboring assets or redundant sensors to define and have an average and so on. So it's a tremendous effort. And the AI will play the biggest role to avoid these manual work and having the challenges to get the information in the right way. Because if I don't have the right data, whatever I do after, like even the recommendation, it happened to us when we share recommendation, whether high, this is mainly for wind or conventional, or even like wind, where we have like high vibration. It's simply, it was a sensor, and your theory is completely deviated from reality. And this is, it will always be there, especially when you have hundreds of the sensors across the plant.
So we already see within kind of the GCC region itself, we've got DEWA already adopting to the VPP plants already. Have you got any cases, Hiba, that you could kind of elaborate on in regards to plants that potentially already digitalized or in a manner where are successfully deployed in a digital era?
Yes. So from a let me say, from a operation maintenance, we already have, when I left, like I'm still there, we have around 15 power plants, like across all technologies. We have around 7 PV plants already connected. DEWA, like we and Aqua and DEWA, we have a couple of, like we are developers together, so we have a couple of plants. We, like Aqua and DEWA, are shareholders in the same plant, whether Noor Energy, whether like DY5 and all these aspects. So we have this capability, and we have the full predictive and performance monitoring, both of them, predictive to when it comes to inverters, transformers, and even trackers, and performance, which really to ensure that we are meeting our generation out. So we have that. Now we are working even with the to enhance and put ahead, and this would be my currently my role, to digitalize the process during the construction. So for that, since I'm coming from operations, it will be easy to understand what, like the digitalization to be done in construction. So the investment I need to put in the construction phase. So when we operate the plant, I have the full data in the right way with the right information that it will be there. So from a operation maintenance, we have enough let's say industrialized solutions, and we are operating this way. And it's not only for that, we have a couple of aspects when we talk about like operation, predictive and performance monitoring. It's the value chain after that. So maintain, and then you know, when we talk about logistics and you know, the what we call spare part spare parts, you know, warehouse capability, you know, monitor the spare parts needs. This is a continuous chain with the solar like operation maintenance activities. So we have a couple of sites. Yep.
I think before we kind of close off the session, I would just kind of highlight one topic. What do we do with the recovering of performance data which potentially has been lost during the kind of either construction stage or during the monitoring and O&M stage? So I'd like to get the take on that from Scott and also from GPM on that. So Scott, first, if you could just expand on that particular topic.
So when we talk about data or cleaning of data or missing data, This is really about the machine learning and behaviors of assets. So from an analytical point of view, within a normal digital twin environment, it normally rectifies and simulates in real time exactly the behavior of that particular asset or assets in a region, as an example. But understanding machine learning is very much about a time-based series. Whether that asset has been installed today or last month, last year, etc. It's really understanding that from our point of view, it's analyzing, simulating, and really highlighting whether that's actionable alarms, as an example, preventable maintenance, etc., in a digital environment. So from a dashboard point of view, it's giving that insight. And key to all of this is as we all say, and we've said for nearly an hour, it's about trusting the data. But that's the key in all of this, because it's really fundamental to digitalization in any form. And from 3E's point of view, it's really making sure that data is acceptable every minute of every day of every week of every month, every year. And that's our take on that.
So GP, what's your perspective on that data loss and how that could potentially affect the assets during that kind of missing period?
Yeah, I mean, there are many ways to tackle this problem, either from a software point of view, so using artificial intelligence with the hindcasting techniques, which is something that we constantly do and deliver on the monitoring side, but also on the resource forecasting side, where if you are missing some data coming from the resources, you can then collate and run something that is called an ensemble to regain control of the forecasting. I will also mention that for us, it's probably a little bit easier because we are suppliers of also hardware, and that enables us to handle the situation in an easier way. So an hybrid approach to storing data is something that gives us an advantage, because by combining the on-site storage of data plus the cloud solutions, we have lower chances of losing any data that are coming from our customers. So I'll probably say that there are two sides to this question and to this problem. One is hardware and how you store and save data, and the other one is hindcasting, so soft and AI to solve this problem with the hindcasting.
Great, thank you for that. So to conclude the session, there's a few questions arised from the listeners today. So I think it comes back to yourself in regards to the specific challenges and considerations when implementing AI on the solar projects and the asset managements in the MENA region, and what trends are foresee in the integration of AI technologies within the renewable energy sector in the near future.
Well, we are seeing a lot of trends, and we are spending a lot of effort in research and development. So predicting what's happening to the inverters, which is something that is quite close to your business, it's something that we are spending a lot of effort on. So expected power of inverter based on artificial neural networks. Another one is predictive maintenance of inverters. So we model the normal behaviors using autoencoders and self-organizing maps, and this will help us predicting what the potential inverter failures are going to be. Another thing that we are doing is focusing on inverter anomaly detection. So what we do is we use, again, artificial intelligence to identify previously unseen operational conditions in solar inverters, and then robust parameter reconstruction. So going back to whether you're missing or not data, we are capable of predicting whether data is missing and reconstructing by combining several sources of data. We look at health monitoring of solar PV plants. So we identify up to 15 neighboring plants that are performing in a certain way, and essentially identify the outliers, again, based on AI and machine learning. And last but not least, long-term degradation of solar PV plants. So estimated by modeling the plant's power production, as a function, of course, of the environmental condition. And then we calculate the degradation rate, and then we try and identify if there are any anomalies or if something is happening to specific plants. So those are the areas where we are expanding in terms of research and development. We are leaning on DNV, which is a much bigger organization than Green Power Monitor. But we've got something like 2,500, 3,000 renewable experts in DNV in energy systems, and then we've got dedicated teams that work on research and development, full stop, without any commercial insights. And we're leaning on both those teams to develop these new technologies alongside my team that is full-time dedicated to advanced technologies and advanced analytics.
Great. So I think that leads on to a very similar question in regards to the health of and minimizing the failures that would typically occur. I think, Hiba, you did touch on that earlier on. And if you could just elaborate from the question from the audience today on the predicting the data and the health to minimize the system failures.
Yes, so for that, this is what we launched like in NOMAC, and let me talk like my because I was leading this implementation earlier. In NOMAC, in order to start with that, we need to define what are the failures that we are looking for. You know, we create this, we call it like a blueprints, the diagnostic failures that we are looking for, and then for every failure that we are like for a solar is a straightforward the list of failures that we face, and then from there we define the how we call it, the sensors like associated to give an indication if we are going to that failure or not. So this approach that we work with in NOMAC to define the like machine learning, create the pattern for these sensors together to define if any deviation out of these sensors, this means that we are going through a failure, whether inverter, transformer, and then the trackers. And then of course on top of it, we are working to have regular drones screening to detect the heat, the concentration heat on the panels, and so on. It all starts with the fleet approach that we have, defining the list of repetitive failures that we are facing, and then work toward to define the pattern, the baseline pattern for them, and then proceed. This is what Giuseppe as well, Giuseppe mentioned, how they are based on from digital twin, define the diagnostics, and then monitor using the AI algorithm.
Great, thank you for that, Hiba. So just to we've just got a couple of minutes left now. I just want to fire that over to Scott as well. What's your take on that, on predictive maintenance and minimizing the system failures occurring on plants?
So from an analysis point of view and from a digital twin point of view, it's really about understanding all the way down to string level the behavior of those assets. You know, there's from a digital twin point of view, we have 21 categories, of which 13 are recoverable, as an example of a platform. And it's really that insight to say, okay, we understand there's a failure, but what is the failure? You know, analyzing that core data, that core behavior of that asset is something which any digital platform needs to do to give insight, to recover that potential loss, and a call to action. So that is really the key of a digital platform, is really from an operational point of view, it's a call to action. And from an analytical point of view, it's really about understanding the data, trusting the data, and preventing that over time in the future. So when we talk about recoverable losses, that could be soiling, that could be shading, that could be deviations, as a few examples in everyday life of a solar asset. But yeah, it's really about inciting the user or user groups to a call to action. And that's something what Digital Twin is there to do every day.
Thank you, Scott. And just lastly, Mohammed, just to finish off the last 30 seconds, what's your last point of view on that?
From our perspective, as we are not a real-time monitoring, I mean, if you have the right foundation from the beginning and you are not lazy, because, you know, any task on site can be also postponed if you did all the digitalization of all the components from day one, and you took all the needed visual inspection, and you are doing like condition monitoring, correct condition monitoring, and having an IEC thermographic inspection on the right time, I think you are ensuring for sure a quality of power and smarter ONM in the future. I just want to answer someone's question that I really find interesting, which is the VR, because I think this is just came to my mind as we are talking about the mobile app application and the portal. The VR is a very good future technology. I think the other future technology are the autonomous drones that you can just control remotely. That would be also great. But also the VR will also will digitalize the digitalization. I mean, if you are on site with your mobile app talking to your colleague in the office, seeing the portal, if he will use the VR, what do you call this, the VR glasses, he can be with you on the same site and also touch the digitalization again. Yes, so this is a future technology that will happen also in the near future. Yeah.
Just to add on that, Aqua and starting with that, and NOMAC to have this initiative in Jiwa.
Without avatars. Exactly.
Right, guys, thank you very much all for joining today. I'll hand it back over to Hind, and we all thank everybody for joining online and listening in. You're all welcome to reach out to us after the session for further more deep dive into the topic of digitalization and AI.
Indeed, thank you so much. Thank you, Rizwan. Fantastic job. Thank you to the over 100 attendees that we had here today. And thank you to all of the speakers present and to Solarabec, our partner on this webinar and most of our webinars. So thank you, guys. We look forward to seeing you on our next one. Thanks.
Thank you. Pleasure.
Have a nice day.